Day 15 notes, matrix operations. So we're going to talk about matrices today, and a matrix is simply a way to organize data. And the dimensions or the size of a matrix is rows by columns. Rows go left to right, columns go up and down, vertical. Okay, so let's go ahead and begin. Let's go ahead and add and subtract matrices. Now, in order to add and subtract matrices, the dimensions must be the same, exactly the same, okay? So, if we take a look at this first example here, where we're adding these two matrices, first let's just identify the size of these matrices, all right? So, if we take a look, we have 1, 2, 3 rows, so we'll have a 3 by, and then the number of columns. So the number of columns is going to be 2. Those are going to be our vertical. All right, so 3 by 2 are the dimensions here. All right, so what are the dimensions of the second matrix? Well, we have 1, 2, 3 rows again, and we have 2 columns vertically, so we're also a 3 by 2. So since we can, since these matrices are identical in size, we can go ahead and add the 2 matrices. Now, when we're adding the matrices or subtracting the matrices, we add or subtract the components or the elements that are in the same exact location. So for instance, I'm going to have 2 minus a negative 1. All right, and that's going to go in that same position in my new matrix. So 2 minus a negative 1 becomes 2 plus 1, which is simply 3. And then we're going to have 1 minus a negative 9, which becomes 1 plus 9, which is going to be 10. And then we're going to have 3 minus 4, so we'll get negative 1 in this next position. And then 6 minus 10, and that will give us a negative 4. And then finally, moving to the last row, 2 minus 7 gives us a negative 5. And then finally, negative 3 minus a negative 4 goes to negative 3 plus 4, so that should be a 1. And what we should notice is the dimensions of our new matrix should also be 3 by 2. 3 by 2, which they are in this case. In this second example, let's go ahead and talk about the size or the dimensions of these matrices to see if we can add them together. So this first one is a 1 row by 3 columns. This second matrix is 3 rows by 1 column. Those are not identical, okay? Not the same dimensions. So therefore, we cannot add them together. Okay, so no solution here. Cannot do it. Dimension mismatch. All right? The next thing we're going to talk about is scalar multiplication. So scalar is simply a coefficient in front of a matrix. So each element of the matrix is multiplied by the scalar or the coefficient, that number out in front. So it's just essentially we're distributing it to every element inside. So our dimensions should not change. They will not change. And all we're going to do is multiply negative 3 to everything inside. So negative 3 times 2, we get a negative 6. Negative 3 times negative 23, we get positive 69. Negative 3 times 1 is negative 3. Negative 3 times 5 is negative 15. Negative 3 times 11 is negative 33. And negative 3 times negative 8 is positive 24. And our dimensions, again, still should stay the same. And in this case, we've got 2 rows by 3 columns. Now we're going to get into matrix multiplication. So a little different in terms of the dimensions here. The dimensions for the matrices don't need to be identical in order to multiply. However, what does need to be true is the columns in the first matrix have to match the rows in the second matrix. So as I line up their matrix or their dimensions, these middle guys need to match, okay? And I'll tell you why as we get into our example, okay? So the columns in the first must match the rows in the second. After we go through our example, we'll talk about how we can determine the dimensions of our product matrix. So let's just jump straight into this first example here, where we're going to multiply. So the first thing I need to test is, can we multiply these two matrices? So we have a 2 by 3, 2 rows by 3 columns, and the second matrix is a 3 by 2. So if we line these up, since these match, we can go ahead and multiply. Okay, so now when we get into actually multiplying, since we can, I like to highlight the rows in my first matrix and the columns in my second matrix. Because what we should notice is that each of these, this row in this first matrix has the same amount of elements as the columns in the second matrix. And what multiplication is for matrices is really a combination of multiplying and adding, okay? So we are going to set up our product matrix. So our product matrix, I'm going to have row 1, row 2. I'm going to have a column 1 and a column 2, all right? And we'll talk about how we get here. So what goes in row 1, column 1 of my product matrix is row 1 times column 1, okay? Row 1 of matrix 1 times column 1 of matrix 2, okay? And what we do is we multiply each element, all right? Element 1 times element 1. Then we're going to add that to the product of element 2 times element 2. And then plus element 3 times element 3, and so on and so forth. So what's that going to look like? Well, we have 2 times 3 plus element 2 is 3 times 7. So plus 3 times 7. Now we add that to element 3 times element 3. So plus 1 times 2. So that is in row 1, column 1. Now we're going to do the same thing for row 1 times column 2, okay? So that's going to go in position row 1, column 2 of our new matrix. So again, element 1 times element 1 plus element 2 times element 2 plus element 3 times element 3. So what does that look like? It's going to be 2 times 1 plus negative 3 times 3 plus 1 times negative 4. Okay? And now we've covered this first row has been multiplied by each of the columns. Now we can move on to row number 2. So row number 2 needs to be multiplied by column number 1, and then row number 2 needs to be multiplied by column number 2. So again, row 2, column 1, row 2, column 2, and then the elements. So row 2, column 1 is going to be 5 times 3, element 1 times element 1, plus element 2 is 10 times element 2 is 7, plus element 3 is negative 8 times element 3 is 2. So now we've covered row 2 times column 1. Now we're going to go row 2, column 2, and put that in row 2, column 2. Okay, so element 1, 5 times element 1 is 1, plus element 2 of 10 times element 2 of 3, or plus element 3, 8, negative 8 times element 3 of negative 4. And now all we need to do is clean up these elements. And when we do that, we're going to have 2 times 3 is 6, plus 3 times 7 is 21, plus 2, we're going to get 29 in row 1, column 1. In row 1, column 2, we get 2 minus 9 minus 4, so negative 11. In row 2, column 1, 15 plus 70 minus 16, we're going to get 69. And then in row 2, column 2, 5 plus 30 plus 32, we're going to get 67. Okay, so now let's talk about the dimensions of this product matrix. So we have 2 rows and 2 columns. And what I want us to look back at is, what did we start with and what did we notice? Well, what we should notice is these outsides become the product, okay? So the rows in the first, let's go ahead and mark that up above, okay? The rows, or the new dimensions, of the product will be the rows of the first by the columns of the second. And that will always be the case. So that's how you can kind of verify that your multiplication was correct and you set everything up correctly. So in short, I had a 2 by 3 times a 3 by 2. I first zoom in on the middle part. The columns of the first match the rows of the second, so I know I can multiply them. And then I can think, well, that means the product is going to be the rows of the first by the columns of the second. I will have a 2 by 2 matrix in the end, and that's exactly what we had. Let's take a look at this next example. So the first thing we do is we identify our dimensions. So this first matrix has 3 rows by 2 columns. This second matrix has 2 rows by 2 columns. So I box these guys. Do they match? Yes, they do. So we can go ahead and multiply. Thinking ahead, what are the dimensions of our product matrix going to be? Oop. So our product will be a 3 by a 2. So 3 by 2 is what we should get in the end. So if it helps you, highlight your rows in the first and your columns in the second. And I want you to go through and try to multiply this on your own. I'll do the same, but pause the video, try it, and then come back and check how you did. Okay, well, as you can see, I ended up with a 3 by 2 matrix. Did you get the same matrix that I did? So row 1 times column 1 goes in row 1, column 1, element 1 times element 1, plus element 2 times element 2. Okay, and as you can see, check your work here and see if you have any questions, and make sure to ask in class. This last example here, let's see if we can multiply. So again, we always start by mentioning the dimensions. So this first one, I have a 3 by 2, okay, 3 rows, 2 columns. The second one, I also have a 3 by 2. So I box these middle ones, and what do we notice? They do not match. So we cannot do it. This product does not exist. And why? Because the columns in the first do not match or do not equal the rows in the second. Okay? So this was a nice easy one. We can't even do that one. It does not exist, that product, because of the fact that the columns in the first matrix do not match the rows in the second. So therefore, we're done. If you have any questions on adding, subtracting, multiplying by a scalar, or multiplying matrices altogether, make sure to ask next time in class.